Jai Hind all of you. I'm Dr. Rahul Bansal from Ajay Kumar Garg Engineering College, Ghaziabad. So this one is the next video lecture for the electron devices, KEC 301. So let us start. So in this video lecture, we will be discussing about the common emitter characteristics, input and output characteristics. In the previous video lecture, we had discussed about the common base input and output characteristics, right? So first we will define the different region. Like previously we had already discussed about this. What is active region? In the active region, both the junctions, that is emitter based junction and the collector based junction, are then in the active region, this emitter based junction is forward bias, collector based junction is reverse bias. In the cutoff region, both the junctions are reverse bias, and in the saturation region, emitter based junction is forward bias and the collector based junction is also forward bias, right? So this we have already discussed in the previous video lecture, right? So before going to the characteristics of input and output characteristics, we must know about the H parameter model, right? So H parameter, what does it says? V1 equal to H11 I1 plus H12 V2 I2 equal to H21 I1 plus H22 V2, right? So this is valid for the a common BJT which consists of like two port, input port and output port, right? So how to proceed for the input and output characteristics? Input characteristics is in between V1 and I1, keeping output voltage constant. That is, it is in between V1 and I1, and we should keep this V2 as constant. So this is called as the input characteristics. Now output characteristics. Output characteristics is in between I2 and V2, keeping the I1 as constant. This is called as the output characteristics. Now for the common emitter amplifier, if you see, this is the common emitter amplifier for NPN transistor, and this one is the common emitter amplifier for the PNP transistor, NPN the PNP transistor. Now for this NPN transistor, if you see carefully, what is V1? As we have discussed in the previous slide, what is V1? V1 is IB. What is V1? V1 is plus minus VBE. What is I1? I1 is IB. Now output, at the output port, if you see, what is I2? IC. And what is V2? VCE, right? So input characteristics will be in between I1 and V1, keeping output voltage constant. That is, input characteristics is in between IB and VBE, keeping VCE constant, right? So next is output characteristics. Output characteristics is in between VCE and IC, keeping input current constant, that is IB constant, right? So if you see the characteristics, so this is the characteristics for common emitter amplifier, right? This is also called as the base characteristics, right? So it is in between VBE and IB, keeping VCE constant, that is output voltage constant, right? So how do we get this different plot for this, right? So this is due to the early effect. right? So why this early effect is causing this? Because if you see the circuit diagram carefully, right? So this if you consider, right, so this positive VC is actually causing the reverse biasing at the collector base junction. Correspondingly, the effective base width will reduce and the recombination will also reduce. What is the effect of this? Due to this, effective base width will reduce and correspondingly IB will decrease, right? So we will have less value of IB for greater value of VC. So this VC, we have taken one example, that is VC equal to 20 volt, we are getting less value of IB. For VC equal to 1 volt, we are getting higher value of IB for particular value of VB. So this is due to the early effect. So this is due to the base width modulation or early effect, right? Now next is, if you see carefully, output characteristics. So output characteristics is in between a VCE and IC, that is output voltage and output current, keeping input current constant. That is, what is input current? Input current is IB. So IB is to be kept constant. Okay. So this IB is to be kept constant for IB equal to 0, for IB equal to 10 volt, for IB 20 volt, and so on, right? Now we have to define the different region of operation, right? Active region. In the active region, emitter base junction is forward bias, collector base junction is reverse bias. So if you see this circuit diagram, emitter base junction is forward bias. It means that this IB is greater than 0. IB greater than 0 signifies that emitter base junction is forward bias, right? Next is VCE is positive. VCE is greater than this VCE set. A particular value of VCE is like fixed, such that if at all VCE is less than this saturation, that is VCE set, then it is said to be reverse bias, and if it is greater than this, it is said to be forward bias. If at all VCE is greater than this VCE set, it means that collector base junction is reverse bias, right? A particular value is set, right? This value is called as a VCE set, right? So VCE is greater than VCE set, it means that this emitter collector base junction is reverse bias, and correspondingly VCE is greater than VCE set. It means that collector base junction is reverse bias, right? So the region where IB is greater than 0 and VC is greater than VC set is said to be active mode. So this region is active region. In this region, transistor is working in the active mode. IB is greater than 0 and VC greater than VC set is said to be active mode. Now, if you see second case, saturation mode, IB is greater than 0, emitter base junction is forward bias, and VCE is less than VCE set. It means that collector base junction is also forward bias. So this region, this shaded region, where VC is less than VC set and IB is greater than 0, is the saturation region. Both the junctions are forward bias, right? Next is, whenever this VCE is greater than VC set, it means that emitter base junction is, this collector base junction is reverse bias, and IB is equal to 0. It means that emitter base junction is also this reverse bias. So this region is called as the cutoff mode, right? Now, this output current, that is IC divided by IB, is called as a beta, right? So you can just define beta value, IC divided by IB. So in the previous video lecture, we had discussed about the common base configuration in which the output voltage was IC and input current was IE. So the ratio of the output current and input current is called as the alpha. Alpha is equal to IC divided by IE, right? Now, this is all for this video. Thank you all of you. Thank you.